Now in this video we are going to take up one more problem on projections of lamina. The lamina problem reads as a rectangular lamina of 20 mm by 30 mm rests on HP on one of its longer edges. The lamina is tilted about the edge on which it rests till its plane surface is inclined to HP at 45 degrees. The edge on which it rests is inclined at 30 degrees to VP. Draw its projections of the lamina. So here he says a rectangular lamina of 20 mm by 30 mm rests on HP on one of its longer edges. Since it is resting on HP on longer edge, which is the longer edge here? There are two edges here. One is 20 mm and the other one is 30 mm. Which is longer here? 30 mm. So the longer edge has to be perpendicular to VP. So that is the first condition. The lamina is tilted about the edge on which it rests till its plane surface is inclined to HP at 45 degrees. So since the surface inclination is given with respect to HP, obviously we have to start the problem from HP. Where is HP? HP is below XY line. So that means HP, the image what you get is the top view, and hence we need to start the problem from the top view. So how to start? Let us see now. First we'll go for the initial position of the drawing. So here this is the first quadrant wherein you have vertical plane and the horizontal plane. So we have a rectangular lamina of 30 mm by 20 mm such that one of the longer edges is resting on HP. So make that longer edge perpendicular to VP. You have two longer edges which are perpendicular to VP. Which are the two longer edges perpendicular to VP? One is AD and the other one is BC. So AD will go to be 30 and BC is also 30. AB will be equal to 20, CD will be equal to 20. So it constitutes a rectangle of 30 mm by 20 mm. So here when you look from the front view, you can see that you are going to get a line in the vertical plane. Why? Because this surface is perpendicular to VP. Therefore, you are getting a line in the vertical plane. And since the surface, all the edges are parallel to HP, therefore you are getting the true length in HP. What is the true length of the HP? AB and CD will have the true length of 20 and AD and BC will going to have the true length of 30 mm. So AB is parallel to both HP and VP and similarly CD, and BC and AD is parallel to HP but perpendicular to VP. Therefore, you are getting a point in the front view, that is this point and this point. So obviously since we have to rest on one of the longer edges, so that longer edge, if you either you can tilt it on A dash D dash or you can tilt it on B dash C dash. So this is how you will be able to analyze the first position of both in the front view and as well as in the top view. Now how to write this in the orthographic view? First we need to draw the XY line and you mark VP and HP. So first you measure in HP, you measure a distance of 20 mm. And then from there you measure 30 mm. And then again from this point you measure 20 and then from here you measure 30. So that means you have a rectangle of ABCD. You mark them as A, B, C, D. So this is the top view position what I have written. So once you write a join A to B, B to C, C to D and D to A with a dot line. So AB is parallel, AB and CD is parallel to both XY line. So that means it is parallel to HP and parallel to VP, and AD and BC is perpendicular to VP and parallel to HP. So then as you look from the front view, A and B is near to the observer, so A dash and B dash is visible, and C dash and D dash, as you look from the front view, C dash and D dash becomes invisible because A and B is overlapping on that C and D. Therefore, C dash and D dash will going to be in bracket. So this is also a longer edge and this is also a longer edge. Which are the shorter edges here? A dash, B dash is a shorter edge and C dash, D dash is a shorter edge. But A dash, D dash and B dash, C dash are the longer edges. So this is how you will be able to read the drawing in the initial position of the first position of the rectangular lamina. Now, so it is resting on one of the shorter edges. So what we have done, we have resting on B dash, C dash is on XY line. And now you are rotating the surface, that is the top surface, by an angle of 45 degrees with respect to HP, such that it is resting on B dash C dash is on XY line, or it is resting on HP. How do I know that? We can see BC is resting on HP, A and D are above HP, such that this entire surface is rotating at an angle of 45 degrees to HP. Since it is rotating on the entire surface is rotated by an angle of 45 degrees to HP. So when you look from the front view, that inclination is seen in the vertical plane. So what we are doing is, we are rotating, as we rotate the surface, the three-dimensional surface, as we are rotating the rectangular lamina at an angle of 45 degrees to HP, what happens to the image in the vertical plane? The image in the vertical plane is also getting rotated. So the surface will going to be inclined to HP but perpendicular to VP. Therefore, in vertical plane you are getting a line. So that is the reason why first we will going to rotate this in the front view. We will going to draw surface is inclined at 45 degrees. To this we are writing the top view. So once you are writing the top view, draw a vertical projector from here to here. Then draw a vertical projector from D and A. Both two will going to intersect at these 2 points. This will going to become A and D. As we know, B and C is resting on HP. So you are getting these 2 points. Then join A to B, B to C, C to D and D to A with a dot line. So now, how do you, so what is going to be the position now? The position is A dash D dash is parallel to HP and B dash C dash is parallel to HP. Therefore, you are getting the true length in the top view. AD and BC both will have the length equal to 30, but whereas AB is inclined to HP, so you are getting the apparent length here, and CD is also inclined to HP, therefore you are getting the apparent length here. What is the apparent length? So here AB will not be having 20 and CD also will not be having 20, but AD and BC will have 30 mm. So this is how you will be able to read the drawing in the second position, front view, and as well as in the top view. Then, how do I should be able to draw it in the sketchbook? So, as we are rotating the first position front view by an angle of 45 degree, take any convenient distance from B dash C dash to this point. So, you mark that point B dash C dash on XY line, because I want the longer edges has to rest on HP. So I am resting longer edge on HP here. Then by using the protractor, you measure an angle of 45 degree with respect to the XY line and draw an inclined line. Then by using the compass, you measure the distance from B dash to A dash with B dash as center, cut on the previously drawn line, that is on 45 degree line. And you mark that point as A dash and B dash. Since we have joined between A dash and B dash, so you join between A dash, B dash with a dot line. Now we need to write the top view for this. Draw a vertical projector from A dash D dash to the top view, and similarly from B dash C dash to the top view. And draw a horizontal projector from A and B and also from C and D. Both these 4 points will going to intersect from A dash to A, you mark this point as A. From B dash to B, you mark this point as B. Then C dash to C, mark that point as C. And from D dash to D, you mark this point as D. Then join A to B, B to C, C to D, D to A with a dot line. So this is how you will be able to reproduce the second position top view. Then the edge which is resting on HP is inclined at 30 degrees to VP. So which is the edge which is resting on HP? The edge which is resting on the XY line. So here, this is the point which is on XY line B dash C dash. What is the position of that point with respect to the top view now? The top view with respect to this point, the top view BC is perpendicular to VP. Now what we want is, we want to be rotated by an angle of 30 degrees. But the inclination given is the true inclination. Now at this point, what should be the length of this, whether it is an apparent length or true length? Since B dash C dash is parallel to HP, therefore you are getting the true length here. And the inclination given in the problem is always gives the true inclination. Therefore, on a true length line, on a true inclination line, you have to get the true length. So since BC is in true length, and the angle given BC to be inclined to VP is also true inclination. From the projections of lines, always on true inclination, you should get the true length. Therefore, we can rewrite the same sketch by rotating at an angle of 30 degree with respect to VP. So therefore, this surface, you rotate this by an angle of 30 degree with respect to VP. That is what we have shown in this shaded area or shaded portion. So this is the actual position of the rectangular lamina in 3 dimension. So now once you get this, now I need to write the top view for this. How to write the top view? Then draw a perpendicular B and C, it is already marked. From D you draw a vertical projector to HP. Similarly from A also you draw a vertical projector to HP. Then you got this point A and D. Then join A to B, B to C, C to D and D to A with a dark line. So this is the top view position. So to this I need to write the front view. How to write the front view? Draw a vertical projector from D to the XY line and then you project vertically up. And similarly from A, draw a vertical projector from A to the XY line and then you take it up. Then draw a horizontal projector from A dash and D dash. Both these 2 points will going to intersect at this point, which is A dash, and this is at D dash. Similarly, draw a vertical projector from B to the XY line because B dash is on XY line. Similarly, C, draw a vertical projector from C and C to the XY line because C dash is also on XY line. And you mark this point as B dash and then C dash. And join A dash to B dash, B dash to C dash to D dash and D dash to A dash with a dot line. So this will going to be the front view, and this whatever it is shown in the red color and whatever it is shown in the blue color, this is the one which is the top view. So this is how you will be able to analyze the drawing in 3 dimension. So how to write that in a sketch now. So we are already come up to this. So in this position, the longer edge which is resting on HP is inclined to VP at 30 degrees. So the longer edge which is resting on HP is now parallel to HP and this is perpendicular to VP. That means it is a 90 degree line with respect to the XY line. Therefore, BC is perpendicular to VP. And since the angle given in the problem to incline to VP is the true inclination, first we need to check whether that edge is in true length or not. What is the true length of BC? The true length of BC is 30 mm because B dash C dash is parallel to HP. Therefore, you are finding the true length in HP, which is BC is 30. Similarly, when come to this point, again B dash C dash is resting on HP. So obviously that line is parallel to HP. Therefore, you are getting the true length in HP. So again here also, even after the rotation of the surface, but still BC is in true length. And since this is in the true length and the inclination given here is also a true inclination, so by using the projections of lines on true inclination line, we need to get the true length. So how to reproduce it? Therefore, you reproduce the same drawing by rotating at an angle of 30 degrees with respect to VP. How to do that? Consider any point and draw a horizontal line. With reference to that point, with respect to that horizontal line, you measure an angle of 30 degree downwards and draw an inclined line. Then by using the compass, you measure the distance from C to B with C as center. Mark this point as C here. With C as center, cut an arc on that inclined 30 degree line. So you mark that point as B. From C, now with respect to BC, you have the protractor here. Then with reference to this line, you measure an angle of 90 degrees and then draw a perpendicular to BC. Similarly with B as center, with reference to BC, you measure an angle of 90 degrees and draw a perpendicular line. Then by using the compass, with reference to C to D, you measure the distance from C to D, which is same as from B to A. With C as center, cut an arc on that perpendicular line. Similarly with B as center, cut an arc on that perpendicular line. Then you mark this point as D and you mark this point as A. Join A to B, B to C, C to D, D to A with a dark line. So now once you reproduce the top view position of the third position, then you need to write the front view. So for that, draw a horizontal projector from A dash and D dash, draw a vertical projector from A and also from D to the front view. These two points or these two lines will going to intersect at this point and also at this point. You mark them as A dash and D dash. Similarly, draw a horizontal. So you have horizontal line on the XY line. From B, draw a vertical projector to the XY line, and from C also you draw a vertical projector to the XY line because B dash C dash is on XY line. So you mark them as B dash and you mark them as C dash. Then join A dash to B dash to C dash to D dash, and D dash to A dash with a dotted line. So this is how you will be able to reproduce the third position top view and also the third position front view. How do I know that my problem is right? Even in the final position also, you can see the longer edge is resting on HP, the edge which is resting on HP is inclined at 30 degrees to VP, since it is the true inclination and what we have got here also the true length. Therefore, we are reproducing the second position top view here, and then the surface is inclined at 45 degrees to HP, and since all the edges are parallel to HP, therefore you are getting the true length here. So the true length of the sides of a rectangular lamina is 30 by 20. Since all the data which was given in the problem has been incorporated in our drawing, therefore our drawing is right. So this is how you will be able to analyze in 3 dimension, and also how we will be able to write the drawing in the sketchbook.